Assalamu alaikum and good morning class. So in this lecture we will be discussing time value of money. So we have here a hypothetical question. So you have applied for a job with a local bank. As part of its evaluation process, you must take an examination on time value of money analysis covering the following questions. So we have here our first question. Draw timelines for, first, a $100 lump sum cash flow at the end of year 2. Second, an ordinary annuity of $100 per year for 3 years. And 3, an uneven cash flow stream of $50, $100, $75, and $50 at the end of years 0 through 3. Okay, so what is a timeline? A timeline is a visual representation of the cash flow stream. And that is very important because it makes it easier for someone to understand how much money comes in at a particular time or period. So we have here at the bottom the timeline. So for the first, it is a lump sum. A lump sum cash flow at the end of year 2. So as what we can see here, on year 0, there is no inflow as well as in the first year, but at the end of the second year, there is a 100 cash inflow. So this is a lump sum. So what is meant by an annuity? An annuity is an even periodic payment. Okay, so even. Okay, so if you can see a constant or the same amount, that refers to annuity. So we have 3-year annuity, ordinary annuity. Okay, so ordinary annuity, the receipt of the cash flow is at the end of that year. So we have at the end of the year 1, we have 100. At the end of year 2, another 100. At the end of year 3, another 100. This is annuity. So for the third, a timeline for uneven cash flow. So uneven cash flow, so it is still yearly, but it is not the same. Okay, so for year 0, it is negative 50. For year 1, that's 100. Year 2, 75. And year 3, 50. So these are the sample timelines for a lump sum cash flow, annuity cash flow, and uneven cash flow stream. Okay, so let's go to our second question. So what is the future value of $100 after 3 years if it earns 10% annual compounding? So by now, we have already understood what compounding means. Compounding means adding an interest to the original amount of money, or what we call the present value. So the present value is the amount of money, the value of money that you have now at present. Future value is the amount of that money in a later time, somewhere in the future, sometime in the future. So the period for compounding is very important, as that will determine how many times the interest is added back to the present value. So we have different types of compounding periods. We have annual compounding. That means only once a year interest is added. So we also have biannually, or semi-annually. So that means in 1 year, interest is being added twice, okay, at the end of 6th month and at the end of 12th month. We also have monthly compounding, and that means interest is added to the original amount of money every end of the month. Okay, so we also have monthly, or we also have daily. So the period for the compounding is very important, so as that will really change the computation process. Okay, so again, the question now is you have 100 now. What is its future value after 3 years if it has 10% annual compounding? So we have here the timeline. So a timeline will guide us on how to analyze the problem, but you don't have to do a timeline every problem. As long as you understood what is being asked, then that is enough. So we have here at today, we have $100 and the interest is 10% and the compounding is once a year. Okay, so what is the amount later at the third year, after 3 years? So we have the formula. The future value is just equal to the present value plus interest. And that's very understandable because that's the common practice that we know. The money plus the interest. Okay, so we also have here the present value plus how to get the interest here. That's simply the present value times interest rate. Okay, or you can also simplify that equation into present value multiplied by 1 plus I, 1 plus the interest rate. So here in our instance, we have the interest rate of 10%. So that's 1 plus 10%, 1.10 multiplied by 100. So that's 110. Okay, so similarly, for future value at the second year, so that's continuing. Let's just continue the process. So now, our present value at the end of year 1 will be 110, and that will be subjected to the interest of 1.1. So that will give us 121. Or in another essence, we have here the present value multiplied by 1 plus the interest times 1 plus the interest kasi twice. Okay, so you do it for year 1 and year 2, making our formula simpler. Present value multiplied by 1 plus I raised to 2. Okay, so 1 plus I raised to 2 because that's twice, already twice at the end of year 3. So 2 here means the number of years. Okay, so you can just try it. Present value, the present value of 100 multiplied by 1.10 raised to 3. And you will still get $133.10. So in general, we can see here that the future value of n, and that n refers to the number of years, is equal to the present value multiplied by 1 plus I raised to that n. Okay, so if you have an n here, the number of years of 3, then our number of n here is 3. Okay, so simply putting it, so future value of, after 3 years, of future value of 3 is equal to 100 times 1.10 raised to 3, so we will get the same, 133.10. So therefore, use this formula to simplify things, especially if we have a big number of years or long number of years, like 20 years. So you cannot do it manually like this. No? Though we know the sequence, the logic of it, but if it is already 30 years, 100 years, 50 years, then it is quite impossible to do the manual. So let's just stick with the formula. Okay, so we have another question here. What is the difference between an ordinary annuity and an annuity Joule? What type of annuity is shown here in the diagram above? How would you change that to other type of annuity? So you can see here what is this annuity? Okay, so just think for 5 seconds maybe, or 3. So this is an ordinary annuity, okay, because it has its payments at the end of each period. So that is, the first payment is made 1 period from today. Okay, so if today, we are talking here about, today is, let's say, January 1, the first payment will be by December 31. Okay, so that's also for the year 2 and year 3. So on the other hand, an annuity due has its first payment today. Okay, so that 100 is supposed to be here if that is an annuity due. So in other words, an ordinary annuity has end of period payments, while annuity due has beginning of period payments. So always remember, ordinary annuity, that's December 31. Annuity due, that is January 1, still of the same year. Okay? So, an ordinary annuity. So, if we want to convert this to annuity due, we will shift our payment to the left. Okay, so making this here, let's ink this one. So we can have here 100. Okay, here another 100. Here another 100. Okay, so you end up 0 on under payment 3, year 3. Okay, so that is how to convert into annuity Joule. Okay, so we have here our second question. What is the future value of a 3-year, $100 ordinary annuity if the annual interest rate is 10%? So this may sound like the same as what we have answered a while ago, but this is an ordinary annuity. That means that it is not only one-time payment of 100, but rather an ordinary annuity, periodic payment of 100 for 3 years. So we have here an illustration, a timeline. So at the end of year 1, we receive 100. Year 2, another 100, and year 3, 100. So how much would be the future value? Okay, so one approach would be to treat each annuity flow as a lump sum. So we have 100 at once. So what we receive at year 3, we just receive that without any compounding. For the year 2, we have 100 multiplied by 1.10 because it is only for 1 year. So we have 110 here. And we have 100 multiplied by 1.10 raised to 2. So what we received at the end of year 1 will be compounded twice at the end of year 2 and at the end of year 3. So we have 121. So we add them all, 100 plus 110 plus 121, we get 331. Okay, so 3.31, we get 3.31 by multiplying the interest factor. So 1.10 for year 2 plus 1.10 raised to 2 for year 1 and 1 for year 3. So that will give us 3.31. So 3.31 here multiplied by 100, we get 331. Okay, so the formula is just the same, but for ordinary annuity, it is this one 1 plus I, this one. Okay. Okay, so the question is, what is its present value? So if you will have a 3-year ordinary annuity of $100, what will be its present value today? No? Okay, so we have this analysis. So we'll just reverse, no? So by reversing, we mean that if we do the future value, like future value is equal to P times 1 plus I raised to N, in present value, we just reverse it. We will make it the value divided by 1 plus I raised to N. Okay, so in this case, for example, at year 1, that is the value here is 100. The annuity payment here is 100 divided by 1 plus I. Okay, so our interest here raised to N. So we have 1.1 raised to 1. So that's basically 1.1. So you have 100 divided by 1.1. So we get 90.91. On year 2, you just follow the same formula. So the annuity divided by 1 plus I raised to N. So our N here now is 2. So 1.1 raised to 2. Okay? So actually we have 1.21 as denominator. So 100 divided by 1 plus I raised to 2 or 1.21, we get 82.64. Okay, do you follow? So for year 3, we have 1 plus I, 1 plus 0.10 or 1.10 raised to 3, okay? 100 divided by that factor. Okay, so we get 75.13. So you can make the formula A divided by 1 plus I raised to n, or simply A multiplied by 1 plus I raised to negative n. So by having a negative n, that's actually the same as putting that number into the denominator. So we just get the sum total. So 90.91 plus 82.64 plus 75.13. So we get 248.68. Okay, so what would our future value be if it was an annuity due? So remember that if it was an annuity due, our first payment would be by January 1, the year 0. Today, the first day of transaction. Then, another annuity payment of 100 at the end of year 1 and at the end of year 2. So therefore, if it was an annuity due, we will have the 3 payments at the end of year 2. Okay? So, what would be its value at the end of year 3? Okay, so if the annuity was an annuity due, each payment would be shifted to the left. So each payment is compounded over an additional period or discounted back over one less period. So as you can see here, so we have one arrow. So arrow left, no, shifted to the left. Okay, so a while ago it was up to here because the first payment was at the end of year 1. So here it is shifted back to the left. So therefore, we have additional 1 period bonus, no? Okay, so it's an additional of 1 period. Okay, so in this situation, the future value of our annuity due is 364.10. Okay, so you just add another period of 331 multiplied by 1.1, making it 364.10. Or using the same timeline, we have at year 1, 133.10, year 2, 121, year 3, 110. So that is 364.10. Okay, so that ends our lecture for today. So thank you, and this is our lesson for under financial management.